So if you're a Salesforce developer, you've probably been there, right? Staring at your code, wondering where's the right place to fetch my data, or why on earth is my component re-rendering itself into oblivion? Well, the secret to all of this, the key to building really solid, powerful components, is all about mastering the LWC Lifecycle Hooks. So let's do this. Let's break down the life story of a component from the very beginning to the very end.
To really get a handle on lifecycle hooks, let's stop thinking about them as just lines of code. Instead, I want you to imagine that every component has a life story. It has a journey with a clear beginning, a middle, and an end. And at every single one of those key moments in its journey, a special event fires off. And that, my friends, is where our hooks come in.
So what are they exactly? Think of them as these special methods that the LWC framework just runs for you automatically at these key moments. There are entry points. They give us, the developers, precise control over what happens when a component is first dreamed up, when it needs to get data, when it actually hits the screen, and even when it's time for it to go.
And here's the thing about this journey. It follows a very specific, totally unbreakable order. First up, you have the constructor. Right after that, connectedCallback. Then comes renderedCallback. And at the very end, disconnectedCallback. Nailing this sequence is absolutely fundamental. It's the key to understanding and controlling how your components behave.
So let's start at the very beginning with the constructor. This is the absolute first thing that runs. You can think of it like a blueprint. At this stage, the component is being created in memory, but it hasn't actually been built or placed on the page yet. It's just an idea.
Now, what's really important to get here are the rules, the restrictions. The constructor has one job and one job only. Super basic setup, like initializing a variable. You absolutely cannot touch the screen, what we call the DOM, because, well, the component isn't on the screen yet. It's just a concept floating in memory. And that's also why you can't fetch data. The connection to Salesforce simply hasn't been made.
In this example right here, this shows you the golden rule. You must call super first thing in the constructor. Seriously, no exceptions. If you forget this one little line, your component will just fail to initialize. It'll break. It is the essential first step that sets up all the standard LWC magic. All right, so our component's blueprint has been created in memory. Now for the next big step, connectedCallback. This is the moment it officially goes live. This hook fires the second your component is actually inserted into the page's structure, the DOM. It's now a real thing the user can interact with.
And this brings us to probably the most common question LWC developers have. Where do I fetch my data? This slide makes the answer crystal clear. You never do it in the constructor. The component just isn't ready. connectedCallback? Yes, that is the perfect and the correct place to make that initial call to Apex and get your data loaded up.
So just burn this into your brain. connectedCallback is your setup workhorse. This is where you do the heavy lifting. You load your data, you subscribe to events, you get any complex initializations done. This is the main setup phase for your component's entire interactive life.
Okay, next up, the component is on stage, the lights are on. The renderedCallback hook fires after the component's UI has been rendered and is actually visible to the user. This one is all about reacting to what is physically on the screen.
But, and this is a big but, here comes a really important warning. Unlike the other hooks, renderedCallback can run many times. It runs every single time the component's display updates. So if you change a property inside this hook, guess what? That change triggers another update, which runs the hook again, which triggers another update, and bam! You've just created an infinite loop that will crash the page. So what is it actually good for then?
Well, it's the perfect spot to interact directly with the on-screen elements. Think, applying a third-party charting library or doing some complex UI calculations. But the key to using it safely is to control when your code runs, and the best practice is to use a simple Boolean flag, a little gatekeeper, to make sure your logic only runs once.
And this code snippet shows you the perfect solution. This pattern is called a guard clause. It's so simple but so powerful. We just create a flag, something like this dot is rendered. The very first line of our method checks it. If it's already true, we just exit immediately. If not, we flip it to true and then we run our logic. This simple little pattern guarantees our code only runs one time, and it completely prevents that nasty infinite loop.
Every life has an end, right? And for our component, that final bow is the disconnectedCallback. This hook fires just before the component is removed from the page. It has one and only one job: cleanup.
Think of this hook as the cleanup crew. If you subscribe to a message channel or you set up a timer back in connectedCallback, this is where you must unsubscribe and clear them out.
Forgetting to do this is a classic way to create what we call memory leaks, these lingering processes that just hang around and slow down your entire application over time.
Okay, so we've gone through all the theory. Now let's put it all together into a practical toolkit so you can confidently pick the right hook for whatever job you're facing.
This table right here, this is your cheat sheet for real-world scenarios. Need to just initialize a simple variable? Use the constructor. Need to fetch data from Apex? connectedCallback is your go-to. Need to work with a third-party UI library on the screen? Do it in renderedCallback, but with a guard. And if you've got a subscription to clean up, you use disconnectedCallback. It really is that straightforward.
And just as important as knowing what to do is knowing what not to do. This slide covers the biggest traps. Trying to call Apex in the constructor or touch the DOM before it's ready are classic mistakes. Forgetting that guard clause in renderedCallback or just blowing off your cleanup duties, trust me, those will lead to some major performance headaches down the road.
So let's wrap it all up with your final best practices checklist. Number 1, keep the constructor simple, basic stuff only. 2, make connectedCallback your main hook for data loading and setup. 3, use renderedCallback carefully and always with a guard flag. And 4, always clean up after yourself in disconnectedCallback. Follow these 4 rules, and you are going to be writing cleaner, more professional, and way more performant components.
At the end of the day, mastering the component lifecycle isn't just about making your code work today. It's about writing code that's robust, efficient, and easy for someone else, or even you 6 months from now, to maintain. It's about being a professional. So the question I want to leave you with is this: when you look at your own components, is your code truly built to last?